I sent to you, never got into you, no matter how hard I try. Can I call you home? No matter how hard I try.
Last month, for the first time since 1972, NASA released a blue marble, a single snapshot of the Earth taken from outer space. And so much has changed in the decades between that first picture and the second. Borders have shifted, generations have come and gone. Our global population has nearly doubled. But one thing hasn't changed. Our planet is as beautiful as ever. It still looks blue. And it's as vast, but also as fragile, as miraculous as anything in this universe. This blue marble belongs to all of us.
So hey guys, Jeff here, and today I want to share with you this article that's on nasa.gov. It's about Robert Simmon, aka Mr. Blue Marble. It's from about 3 years ago, and it's a little interview. They ask him a bunch of questions, and I found some of his answers rather interesting. So let's take a look. What do you do, and what is most interesting about your role here at Goddard? How do you help support Goddard's mission? His answer was, my role is to make imagery from Earth science's data. Okay, he makes images. He does not take photographs. I turn data into pictures. I look for new interesting events that NASA satellites have seen or that are hidden in the latest data to find anything interesting that shows off NASA's unique capabilities. Yeah, unique capabilities as in creating CGI Earth planets. It's not unique at all. What is the coolest thing you've ever done as part of your job at Goddard? The last time anyone took a photograph from above low Earth orbit that showed an entire hemisphere, one side of the globe, was in 1972 during Apollo 17. NASA's Earth Observing System, EOS satellites, were designed to give a checkup of Earth's health. By 2002, we finally had enough data to make a snapshot of the entire Earth, so we did. The hard part was creating a flat map of the Earth's surface. Then we wrapped the flat map around a ball. My part was integrating the surface, clouds, and oceans to match people's expectations of how Earth looks from space.
Nike Hercules, Stripey XM33, Thor, Johnston Island was the center of launch and experimental activity for the 1962 high-altitude weapon effects testing termed Operation Fishbowl. But Johnston Island was only the core of Fishbowl activity. Radiating out in all directions from this tiny island, 800 miles southwest of Hawaii, were instrumented stations, 266 of them, at sea, in the air, and on land, encompassing a major portion of the Pacific Ocean, all geared to collect effects data from nuclear bursts at high altitudes.
I'm waking up to ash and dust. I wipe my brow and I sweat my rise. I'm breathing in the chemicals. I'm breaking in, shaping up, and checking out on the prison bus. This is it, the apocalypse. Whoa, I'm waking.
Orion is getting ready to launch. My name is Kelly Smith, and I work on navigation and guidance for Orion. Orion is NASA's next-generation spacecraft. Built with versatility in mind, it can take astronauts deeper into space than we've ever gone before, to an asteroid or even onto Mars. For these missions, Orion has to be one tough spacecraft, withstanding high speeds, searing temperatures, and extreme radiation. Like the setup for a roller coaster ride, this is the big climb we've been waiting for. We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home.
Jesus Christ. Houston. We're on the fucking moon. Over.
Every hour, hundreds of tourists from all over the world with cameras at the ready gather in front of the old town hall to enjoy a fascinating mechanical performance which in the Middle Ages was considered one of the wonders of the world. The Prague Astronomical Clock, which for 600 years has been one of the greatest treasures of the city, still amazes people with its procession of apostles, moving statues and visualization of time like no other instrument in the world. Still amazes people with its procession of apostles. And no one noticed a projection of the flat earth? Maybe moving statues and visualization of time like no other instrument in the world, directs people away from the true projection. Legends about the origins of the Prague astronomical clock are many. The most famous one, however, is that it was built by Master Heinus in 1410.
Time zones make perfect sense on this map. So this is the representation of the time zones that they give us. Does this make any sense to you? Or does this make more sense? The hours on the clock are the different time zones. Everywhere you look on this map, everything we need to know about the world we live in is right in front of you.